Okay, so we want to solve this time equation in more concept, especially on the limiting reagent. That's my main emphasis, but I'm going to answer the whole question. So 2 grams of pure magnesium ribbon reacted with exactly 100 cubic centimeters of 2.0 mole with this meter cubic hydrochloric acid. So we have been given the concentration, we have been given the volume of the acid, as well as the mass of magnesium ribbon. Okay, so the first question is construct a balanced chemical equation for the reaction. You include the state symbols. So this reaction is between magnesium and the hydrochloric acid. So we have magnesium plus hydrochloric acid. You need to know the formulas of these compounds and the element to produce. Whenever an acid reacts with a metal, it forms a metal salt. So a metal is more reactive than hydrogen. So magnesium will displace or remove hydrogen from each compound to produce magnesium chloride. Okay, I already did the video on how to write the chemical formula of this, so I will put the link in the comment section if you suppose you are not aware how to come up with these formulas. Okay, plus the hydrogen gas which has been displaced there. Now the question says write a balanced chemical equation and we have to include the state symbol. So all metals are in solid state except mercury. All acids are in aqueous. Then magnesium chloride is a soluble salt, which is also aqueous, and hydrogen is a gas. Now we need to balance that. When balancing, it's easier when you start by balancing metals. So here the metal we have is magnesium. So if you check on the left side of the reaction, we only have one magnesium atom. Even on the right side of the equation, we have one magnesium atom. So for a metal is balanced. Now we have to balance chlorine before hydrogen. So here we have one chlorine atom. This side we have 2 chlorine atoms. So for us to balance, we have to put a 2 at hydrochloric acid. So we have balanced for chlorine. Then now we have hydrogen. Here we have 2 hydrogen. Even though we also have 2 hydrogen. So that is a balanced chemical equation. Now, for question 2, determine the limiting reagent for the reaction. So now, how do we determine the limiting reagent for the reaction? You first have to calculate the number of moles for the substance whose mass is given. So we calculate the number of moles for a substance whose mass is given using the balanced chemical equation. So likely you have already written the balanced chemical equation. So let us find the number of moles for a substance whose mass is given. In this case, this mass is for magnesium ribbon. So calculate the number of moles for magnesium. So we say number of moles is equals to mass of a substance over the molar mass of a substance. In this case, since this is an element, we can just say atomic mass, which is the AI. So number of moles is equals to mass of magnesium given in the question is 2. So we have 2 divided by the atomic mass of magnesium from the periodic table, which is 24. Now you need to divide the 2 divided by 24. What are you getting? 2 divided by 24?
0.083.
0.083 moles. Okay. Now that we have the number of moles for a substance whose mass is given, you need to write the necessary mole ratio. We need to write the necessary mole ratio because here we want to know the limiting reagent between magnesium as well as the hydrochloric acid. So since we have calculated the number of moles for magnesium, we must also find the number of moles for hydrochloric acid. So we can only do that by writing the necessary mole ratio. So the mole ratio we are writing there is comparing magnesium and the hydrochloric acid. So we have magnesium here and we have hydrochloric acid there. Now get the number which are in front of this balanced chemical equation. Magnesium, we have 1 in front there, and the hydrochloric acid, we have a 2. Now, since we already have the number of moles for magnesium, write it below. Okay, we round off, it will be 0.08. Write it below magnesium, 0.08 to, we don't know the number of moles for hydrochloric acid. So now we have to cross multiply, which we have x is equals to 0.08 times 2. What do you have? 0.08 times 2? 0.16. These are moles for hydrochloric acid. Now that we have found the number of moles for hydrochloric acid and the number of moles for magnesium, we need to compare using the molarity, meaning the numbers which are in front of the balanced chemical equation. You get that, right? So first compare these two. So we compare starting for magnesium, which will be magnesium over hydrochloric acid there. Now, the number which is in front of magnesium there is 1 over the number which is in front of hydrochloric acid is what? Is 2. And if you divide this, is giving us 0.5. You see that, right? Now, once we have calculated we have compared the magnesium to hydrochloric acid, now we need to compare their number of moles. Magnesium over hydrochloric acid. So we say magnesium, what is the number of moles for magnesium? The number of moles is 0.08. So we have 0.08 over the number of moles for hydrochloric acid, which is 0.16. Now divide this, please.
0.5.
0.5. So we have 0.5. So if you have checked, if you compare what we have here and what we had compared using the molarity there, this is the same. You see that, eh? Now for us to know which one will be the limiting reagent, we need to compare now starting with the hydrochloric acid, which will be hydrochloric acid over magnesium. So what is the number of moles for hydrochloric acid? Is 0.16 over the number of moles for magnesium, which is 0.08. Divide that, what do you have? 2. You have a 2. So if you have checked which one is smaller here, between the one for chlorine, hydrochloric acid, or the one for magnesium, which one is smaller there? Which one is smaller?
0.
The one for magnesium, is it? Yes. Magnesium is 0.5. One for chlorine is what? Is 2. So the one which is smaller is the limiting reagent. So therefore, the limiting reagent in this chemical equation is what? Is magnesium people. You see that, right? Yes. So the limiting reagent is magnesium. Okay, the last question. Calculate the volume of a gas that was involved. Now, since we have already done this, most of the steps, calculating the volume is easy. You get that, right? Calculating the volume is easy. We use the formula . So for us to find the volume, don't forget the number of moles for magnesium and the hydrochloric acid, because we need to use that as a calculating volume for the gas produced. So we say number of moles is equals to volume of a gas over the molar volume of a gas. You see that, right? Number of moles is equals to volume of the gas over the molar volume. Now, the number of moles for this gas, we don't know. You see that, right? So we have to find it using the molar ratio. We can compare for magnesium again. We said magnesium to hydrogen this time, isn't it? Now get the number in front of magnesium, which is 1, and the number in front of hydrogen gas, which is also what? When the numbers which are in front are the same, it means they have the same number of moles. For magnesium, the number of moles we had found is 0.08. If you cross multiply, even for hydrogen will give you 0.08. So when the numbers in front are the same, they have the same number of moles. You get that, right? So we say volume of the gas is equals to moles of the gas, which is 0.08. 0.08 is equals to volume of the gas, the one we want, over the molar volume at room temperature and pressure, which is 24. So you raise this one as a fraction for easy multiplication and cross multiply. Your volume of the gas is equals to 0.08 times 24. 1.92 decimeter cubic. So that is the volume of the gas at room temperature and pressure. Okay, thank you. So we end here. Then if you have any other questions, please you can leave a question in the comment section and I'll be able to respond. Thank you.